project number 176011, named Dynamics and Kinematics of Celestial Bodies and Systems. I can say that this project are clearly separated four topics. Then this is studies of small solar system objects, double and multiple stars, statistical investigation of local kinematics of our galaxy in solar neighborhood, and astrometry and photometry of quasar and webbed objects. The first one, studies of small solar system objects. The research related to the small solar system objects performed within this project could be divided in three main topics. Asteroid families and related studies, active asteroids and main belt comets, and long-term dynamical stability. Double and multiple stars consist actually of investigation of binary stars, determination of stellar masses, verification of evolutionary models, and star formation theories. We can separate three different subtopics: determination of relative position of components, calculation of orbital and linear elements, determination of stellar masses, parallaxes, and absolute magnitude. Statistical investigation of local kinematics in solar neighborhood consists of actually two separate topics: kinematics analysis of the galactic thin and thick disk, and calculation of galactocentric star orbits. Actually, I can mention here also trying Cvetkovic to investigate different functions of galactic potential. The last one, but not least, is astrometry and photometry of quasars and webbed objects. That usually observational topic and consists of investigation of morphology and photometry of quasars, and also Gaia alerts and webbed objects. The theme which let's say about all of people who involved in our project. Mike Kuzmanovsky, you know him, I suppose. He involved in close approach of small bodies, and he calculated masses of asteroids. Unfortunately, he was retired very early from the beginning of our project, actually in October 2011. Dr. Zoran Knežević has a very rich scientific research, and I listed only few. I have to mention he was the first leader of this project when we started actually this project. He works in developments of analytical perturbation theories and of purely numerical methods for computation of asteroid mean and proper orbital elements, developments of new methods and algorithms for identification and orbit determination of moving objects to be used in next generation of observational surveys, then methods to estimate risk of asteroid collisions with the Earth, very interesting topic. He is, I can say, full member of the Serbian Academy of Science and Arts. Unfortunately, he was retired in August last year, but I hope he will help us in the next project call. Dr. Slobodan Ninkovic is involved in, I mentioned a little bit earlier, to introduce different formula for gravitational potential of galaxy, and also he is very active to work with young people. Unfortunately, he also retired as Zoran in August this year. Dr. Zorica Cvetkovic works on observation of usual double and multiple stars. She calculate many orbits, and she belongs to the leading 10 people who calculate much more orbital elements. I skip myself. I just mentioned only that I involved in introducing new observational technique, especially for introduce spectral interferometry. Dr. Goran Damjanovic works on observation and morphology of quasars and photometry and astrometry of quasars and web objects. Natasha Todorovic working on Hamiltonian system and symplectic maps, then slow diffusion in Arnold's web of resonances, and she got the degree in May 2012. Dr. Bojan Novakovic works on dynamics of asteroids families, origin and evolution of the asteroid families, influence on secular resonances between the dwarf planet Ceres and other asteroids. That is very recent results, and he got and defended PhD thesis in December 2011. Milan Stojanovic doing galactocentric orbit of stars in solar neighborhood. He got very recently his PhD degree, actually less than 1 month ago. Ivana Milic Žitnik is PhD student, and she working on role of mean motion resonances in semi-major axis mobility of asteroids. Miljana Jovanovic is also PhD student, and she working in astrometrical observation of quasars and connecting present International Celestial Reference Frame with future Gaia International Celestial Reference Frame. And Dr. Dušan Marčeta was joined to our project in January this year and started to work with new approach to excluding the loopers from asteroid families. So equipment we used to our observations and job is it's telescopes. We used intensively astrometric telescopes on station of Vidojevica, small one called Nedeljković with mirror 60 centimeters, and the largest one called Milanković with mirror with 1.4 meters. I would say here that we have very intensive collaboration with colleagues in Bulgaria, actually at National Astronomical Observatory at Rožen. We use 2 meters telescopes. And the smallest one, 0.6 meters. This is actually our equipment which we used and consist of old SWIG ST10ME camera, Apogee Alta U42, Vers Array 1300B, which belongs to colleagues in now Rožen, and we very recently got a new Andor Ixon Ultra 897 very fast camera, which we plan to use in other equipment to start it with speckle interferometry. I would point your attention only on this column, and you can see the parameters of all of mentioned cameras, and this is actually pixel scale, and you can see that is very close, except for Apogee Alta, which is twice as large than others. Actually, we much more explore this camera and have many results got with this camera, and hope that in next future we will use this new camera. So this is a statistic of published article during these 6 years, and this is international journals where we publish our results. This is leading, and here you can see a jump because of psi was in that year 2013 jumped to C list, and I would say that we published almost 40 articles in leading international journals. This is domestic, and this is conferences. So I would present some selected results which we got during these 6 years. In the frame of asteroid families, I can say the asteroid families are groups of objects originated from a fragmentation of a single parent body due to asteroid-asteroid collision. The families were in focus of our research of small solar system objects. In this respect, several different lines of research have been followed, that are classification of male belt asteroid into family, analysis of long-term dynamical stability of individual family, age estimation, studies of young asteroid families less than 10 megayears old, and observation of family members. Selected result, I will present here some article and say a little bit. This work was based on computation of new synthetic proper elements for a sample of 19,000 asteroids. In this respect, this was the most complete classification of high inclination object at that time. In total, 38 families and many small groups have been identified. I would say that works was continued many years, and the product is asked this site. Then new classification for main belt asteroid, and an automatic approach to excluding the loopers from asteroid family was recently developed by colleagues from our project, and about that you can hear more in Victor's talk. The second topic of this group is studies of young asteroid family, and I can list it this work where they found strong evidence that 11 asteroids likely originated in a racing collision event, and that this group includes a main belt comets P 2006, recently discovered by Pan-STARRS 1 telescopes. They have also determined the age of family to be very young, actually 7.5 mega-year. And next one is a paper where authors analyze race collisional jet from a primitive asteroid, and they that used other way to calculate actually age, which is 1.9 mega-year. So this is very interesting work and completely done by this group. This work reports a significant role of a so far overlooked dynamical aspect, namely a secular resonance between the dwarf planet Ceres and other asteroids, and demonstrate that this type of secular resonance can be dominant dynamical factor in certain regions of asteroid belt. The study shed light on important and entirely new aspect of long-term dynamics of small bodies. It completely changes our understanding of the way in which perturbation of Ceres-like objects affect the orbits of nearby bodies. Here you can see a family, and spread is very small, but driving with secular resonances, which is with Ceres, the spreading testing particle is very clear. And here is final result after 145 mega-year, where spread is very, very wide. This is similar work, but here the authors include the second asteroid Vesta, and got much better picture of complete asteroid belt and influence both of asteroids on main belt asteroid through secular resonances. They got detailed map of location of these resonances and also evaluating the magnitude of perturbation, and found that in some cases the strength of these secular resonances is comparable to that of non-linear secular resonances with the giant planets. The next one is discovery of dark asteroid family in the Okea region, and also this is determination of asteroid family ages, and they so I will be a little bit faster to mention I will explain a little bit this picture. this is precise and powerful chaos of 5 to 2 mean motion resonances with Jupiter. You can see on this panel, this is calculated past the Punov indicator, where included all planets. But here the authors exclude the inner planets, actually Venus, Earth and Mars. And you can see that the main contribution of inner planets is on higher eccentricity, that is eccentricity. And below 0.3, the main contribution is from giant planets. Also, the second result is that authors showed clearly that there are natural transportation routes to near-Earth object. This is some, I can say, route to near-Earth object, and also on other part there are some particles which could escape from the solar systems. So, the next work which I would present is, I can say, my favorite, because I can sentimentally connect it with this system ADS-48, because when I came to observatory, I calculate the first orbital elements for this system. And after many years later, we completely analyze these systems and find that the closest pair is the only pair which has orbital motion, and all other components except that the most distant component F has actually background stars. This pair and this component has common proper motion, and on this picture you can clearly see here we use our CCD frames obtained between 1994 and 2011. All pictures are overlooked in order to have at the same position images of other background components for which the configuration is invariable. The motion of pair AB is clearly seen, but we couldn't show that there are some orbital movement. So we published also measurements regularly, and I would mention this work where we determined more precisely focal length for used detectors on both telescopes. So I will mention these results. These results present very mobility of our 0.6 meter telescopes, and we keep watching alerts, and I can say that we sketch. Supernova 2013 DR in very early phase of burst. So I will point your attention on next two talks, Viktor Radovic and Ivana Milic-Žitnik, and posters number 11, 17, 18, 32, 34, and 35. And shortly mention future work, introduction of speckle technique, and continuation improvement of the present works, and some plan toward the improvement of the methods to complete accurate orbits. Then expansion of existing collaborations and inclusion of new researchers is very important conclusion in the next project call. And thank you for your attention.
You can hide the wrong one.